right, chapter 6, lesson 1b now. We solved one-step subtraction equations yesterday. Today what we're going to do is we're going to solve one-step addition equations, and that's exactly what your learning target is I know how to solve one-step addition equations for a variable. Okay, so the addition property of equality says that two sides of an equation will remain equal when you add the same number to each side. Okay, and it's the same thing like that teeter-totter problem we talked about yesterday with my family and my brother's family. The only difference now is instead of taking one off because one of the kids wanted to go down the slide or the swings or whatever, now we're adding one kid on. Okay, maybe we're adding a whole nother family on. Whatever it is, we're keeping both sides equal by adding something to both sides of the equal sign. Okay, so what that is that if A equals B, then A plus C will equal B plus C, right? If A and B are the same thing, then if you add C to it, everything will stay equal. And that's exactly what the addition property of equality says. Okay, so your key concept here is not much different from yesterday. But to solve one-step addition equations, the first thing we got to do is we have to use the addition property of equality to add a number being subtracted by a variable from both sides of an equal sign to keep the equation balanced, and then just simplify it. So let's just do a couple of examples today. We'll make this real nice and short because it's pretty much the same exact thing as yesterday. Alright, so example 1 says solve 12 equals z minus 8 and then check your solution. Okay, so we're gonna set this up just the same way. We want to get the variable by itself to see what z is really equal to. And so what we're gonna do is we're gonna add 8 to both sides, because if we do that, these just cancel out, and all we're left with on the one side of the equation of this equal sign here is z. Z is the only thing left, right? Because negative 8 plus 8, that just equals 0. We added 8 to the other side, and 12 plus 8, that is 20. So that means that 20 equals z. And now we can go back and we can check our work. We can make sure that we have this right. If we plug in 20 back in for z here, 20 minus 8, well, that equals 12, right? So it checks out. We're happy about it because everything's right. The reason why I put this line here is just to keep everything lined up. If that helps you keep what's on one side of the equation separate from what's on the other side of the equation, you're more than welcome to do that. That's a good habit to get into. Marissa practiced the piano for 32 minutes. She practiced 11 minutes less than her brother did. Write and solve an equation to determine how long her brother practiced the piano. Okay, and if we write this down here, we know that Marissa, her time of 32 minutes is going to be equal to 11 minutes less than her brother. So brother minus 11. Right? Because the brother practiced 11 minutes more than she did, and that's what she's going to have. Okay, and if we plug these numbers back in, we'll see that 32 minutes, that's how much Marissa spent, is equal to the brother. I'm just going to define that variable as b, minus 11. So I've created my equation now, and now I just need to solve. And to do that, I have to add 11 to both sides. I'm going to add 11 to both sides. I like to keep everything very organized. Negative 11 plus 11 is 0, so we're just left with b on this side. And the brother is equal to 2 plus 1 is 3, and 3 plus 1 is 4. So I'm left with 43 equals b. So therefore, Marissa's brother practiced 43 minutes. Okay, and that's all we're doing. So it's the same kind of thing as we did yesterday. The only thing that is different this time is we're just adding if there's a subtraction sign, just to keep everything balanced so we can solve for a variable. All right, enjoy. Peace.